right, here we are. We're talking about Chapter 3, Section 2, vectors, vector operations, not just vectors. And the first question is, if we have an airplane here, and our airplane is flying to the northeast, like so, can we say that the plane is flying both north and east simultaneously? And the answer is yes. Yes, the plane is flying north, and yes, the plane is flying to the east. But the bigger question is, if we know how far to the east and how far to the north, can we figure out how far to the northeast? And not only how far, but this could also be velocity vectors. Its velocity is to the east and its velocity is to the north, therefore it has a combined velocity to the northeast. And how do we calculate it? With the good old Pythagorean theorem. A squared down here, b squared over here equals c squared. Now, I'm going to make an assumption that you guys at this point in your mathematical careers can do Pythagorean theorem. If you're struggling with this, please ask me questions, okay? As we read through questions out of the text, they have this really odd pattern of how they describe directions sometimes. They'll say something to the effect of, the rodeo clown angles at 30 degrees east of north. Like, east of north? What are you talking about, east of north? And so we need to address this. And so I made this little diagram. Let's focus here on the blue one first. Clearly, we are in the northeast quadrant. But is this blue vector showing us, for say, 30 degrees north of east or 30 degrees east of north? So I have my two options. Well, look at it this way. I'm at the east, go to the north of it. So I am on the north side of east with this one. Now look at the purple. How would I describe this one? I'd look at it and say, well, here's east. I'm down below it. So I would be on the south side of east on this one. And over here, the green. Well, it looks like I'm going south and I angled to the west. So that would mean I am on the west side of south. And up here in the red, here's north. I went off to the west of it. So I am on the west side of north with this one. Now I know that this idea right here represents a lot of stress when you're watching videos, or not when you're watching videos, when you're going through problems. It represents stress, understanding how to draw the angle. But I'm going to tell you in a moment, we're going to talk about trigonometry. When you are working with a triangle, let's say you did this red one, and let's say you accidentally treated it as if it was the angle down here. Guess what? This component that you calculate and this component that you calculate, the numbers you found will still be good numbers. They'll just be in the wrong spot. So you'll have good information to work off of at least, and that's a little bit comforting. And then we have one more thing to talk about in this, and that is SOHCAHTOA. Now I know that you've probably encountered SOHCAHTOA in your work, but some of you may not have fully understood it, or you may need a refresher. So let's just say that this is a vector we're working with. Let's say maybe the hypotenuse is 10 and the angle is like 37. And we want to find this, the adjacent. I'm going to, because it's on the x-axis, I'm going to call it the x. Or in the opposite, it's up on the y-axis, so I'm going to call it y. Now, opposite is not always y, and adjacent is not always x. If you turn this triangle, on its point, all of a sudden, the x's and y's, you just reassign them. I'm just saying adjacent is over here and opposite is over here. So let's figure out with SOHCAHTOA here. So sine, I would set this up to calculate. I'd say the sine of 37 degrees. Warning, if your calculator has been reset recently, you may not be in degrees, you might be in radians. So you go hit mode, and you go down like 3, and you put in degrees. So the sine of 37 degrees is equal to the opposite over the hypotenuse. So the opposite here is our y over our hypotenuse of 10. And so to solve that, all you do is multiply by 10. And cosine, if we wanted the x, we would say, what am I writing? That's not even the right letter. This happens when you're trying to write with the mouse. Cosine of 37 degrees is equal to the adjacent over the hypotenuse. So the adjacent is our x over the hypotenuse, which is 10. Again, just multiply the 10 over, and you'll be able to figure out what these two component values are. How are we going to use these numbers in class? Pretty much just like we did it. It'll seem like in most of the problems, you'll be given some angled vector that'll be the hypotenuse and the angle. And you'll be needing to break it down into x's and y's so that you can work with them. Because we know from math class, we can't just add x's and we can't just add y's. So we got to figure some out. We got to figure them out. Plus, there's usually more than one vector involved. Okay. But the moral of the story is we're going to use sine and cosine usually to find the adjacent and the opposite of your triangle. Okay, and if you're watching this one for the first time, not as review, this one did come with a homework assignment. This says 87, 1 through 4, and this one here says 91 through 4, if it happens to be your first time through. Okay? Again, if you're struggling with SOHCAHTOA, please ask me in person. I'm willing to bet we can clear this up very quickly if this is a struggle for you. All right? Good luck.